Section 15 of Familiar Letters on Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Gary Gilbert, 2007. Familiar Letters on Chemistry by Justice Liebig. Letter number 15. My dear Sir, you are now acquainted with my opinions respecting the effects of the application of mineral agents to our cultivated fields, and also the rationale of the influence of the various kinds of manures. You will, therefore, now readily understand what I have to say of the sources whence the carbon and nitrogen indispensable to the growth of plants are derived. The growth of forests and the produce of meadows demonstrate that an inexhaustible supply of carbon is furnished for vegetation by the carbonic acid of the atmosphere. We obtain from an equal surface of forest or meadowland, where the necessary mineral elements of the soil are present in a suitable state, and to which no carbonaceous matter whatever is furnished in manures, an amount of carbon, in the shape of wood and hay, quite equal, and ofttimes more than is produced by our fields in grain, roots, and straw, upon which abundance of manure has been heaped. It is perfectly obvious that the atmosphere must furnish to our cultivated fields as much carbonic acid as it does to an equal surface of forest or meadow, and that the carbon of this carbonic acid is assimilated, or may be assimilated, by the plants growing there, provided the conditions essential to its assimilation and becoming a constituent element of vegetables exist in the soil of these fields. In many tropical countries, the produce of the land in grain or roots during the whole year depends upon one rain in the spring. If this rain is deficient in quantity, or altogether wanting, the expectation of an abundant harvest is diminished or destroyed. Now it cannot be the water merely which produces this enlivening and fertilizing effect observed, and which lasts for weeks and months. The plant receives, by means of this water, at the time of its first development, the alkalis, alkaliners, and phosphates necessary to its organization. If these elements, which are necessary previous to its assimilation of atmospheric nourishment, be absent, its growth is retarded. In fact, the development of a plant is in a direct ratio to the amount of matter it takes up from the soil. If, therefore, a soil is deficient in these mineral constituents required by plants, they will not flourish, even with an abundant supply of water. The produce of carbon on a meadow, or an equal surface of forest land, is independent of a supply of carbonaceous manure, but it depends upon the presence of certain elements of the soil, which in themselves contain no carbon, together with the existence of conditions under which their assimilation by plants can be effected. We increase the produce of our cultivated fields in carbon by a supply of lime, ashes, and marl, substances which cannot furnish carbon to the plants, and yet it is indisputable, being founded upon abundant experience, that in these substances we furnish to the fields elements which greatly increase the bulk of their produce and consequently the amount of carbon. If we admit these facts to be established, we can no longer doubt that a deficient produce of carbon, or in other words, the bareness of a field, does not depend upon carbonic acid, because we are able to increase the produce to a certain degree by a supply of substances which do not contain any carbon. The same source whence the meadow and the forest are furnished with carbon is also open to our cultivated plants. The great object of agriculture, therefore, is to discover the means best adapted to enable these plants to assimilate the carbon of the atmosphere which exists in it as carbonic acid. In furnishing plants, therefore, with mineral elements, we give them the power to approximate carbon from a source which is inexhaustible, whilst in the absence of these elements the most abundant supply of carbonic acid, or of decaying vegetable matter, would not increase the produce of a field. With an adequate and equal supply of these essential mineral constituents in the soil, the amount of carbonic acid absorbed by a plant from the atmosphere in a given time is limited by the quantity which is brought into contact with its organs of absorption. The withdrawal of carbonic acid from the atmosphere by the vegetable organism takes place chiefly through its leaves. This absorption requires the contact of the carbonic acid with their surface, or with the parts of the plant by which it is absorbed. The quantity of carbonic acid absorbed in a given time is in direct proportion to the surface of the leaves and the amount of carbonic acid contained in the air. That is, two plants of the same kind and the same extent of surface absorption, in equal times and under equal conditions, absorb one and the same amount of carbon. In an atmosphere containing a double portion of carbonic acid, a plant absorbs, under the same condition, twice the quantity of carbon. Boussingault observed that the leaves of the vine, enclosed in a vessel, withdrew all the carbonic acid from a current of air which was passed through it, however great its velocity. Dumas Lecon, page 23. If, therefore, we supply double the quantity of carbonic acid to one plant, the extent of the surface of which is only half that of another living in ordinary atmospheric air, the former will obtain and approximate as much carbon as the latter. Hence results the effect of humus and all decaying organic substances upon vegetation. If we suppose all the conditions for the absorption of carbonic acid present, a young plant will increase in mass in a limited time only in proportion to its absorbing surface. But if we create in the soil a new source of carbonic acid by decaying vegetable substances, the roots absorb in the same time 3 times as much carbonic acid from the soil as the leaves derive from the atmosphere. The plant will increase in weight fourfold. This fourfold increase extends to the leaves, buds, stalks, etc. And in the increased extent of the surface, the plant acquires an increased power of absorbing nourishment from the air, which continues in action far beyond the time when its derivation of carbonic acid through the roots ceases. Humus, as a source of carbonic acid in cultivated lands, is not only useful as a means of increasing the quantity of carbon, an effect which in most cases may be indifferent for agricultural purposes, but the mass of the plant having increased rapidly in a short time, space is obtained for the assimilation of the elements of the soil necessary for the formation of new leaves and branches. Water evaporates incessantly from the surface of the young plant. Its quantity is in direct proportion to the temperature and the extent of the surface. The numerous radical fibrillate replace, like so many pumps, the evaporated water, and so long as the soil is moist or penetrated with water, the indispensable elements of the soil dissolved in the water are supplied to the plant. The water absorbed by the plant evaporating in an aeriform state leaves the saline and other mineral constituents within it. The relative proportion of these elements taken up by a plant is greater, the more extensive the surface and more abundant the supply of water. Where these are limited, the plant soon reaches its full growth, while if their supply is continued, a greater amount of elements necessary to enable it to appropriate atmospheric nourishment being obtained, its development proceeds much further. The quantity or mass of seed produced will correspond to the quantity of mineral constituents present in the plant. That plant, therefore, containing the most alkaline phosphates and earthy salts, will produce more or a greater weight of seed